Welcome to the new Transatlantic Cable, a tripartite civil engineering history webinar series. The webinars are coordinated by the History and Heritage Committee of the American Society of Civil Engineers, the National History Committee of the Canadian Society for Civil Engineering, and the Panel for Historical Engineering Works of the Institution of Civil Engineers. Today's installment, recorded on December 14th, 2022, features Tonja Koob marking on Captain George Vancouver's surveying and mapping of the northwest coast of North America.
Well, hello and welcome. My name is Nigel Shrive. I'm from the Schulich School of Engineering at the University of Calgary in Western Canada. I'm a member of the Canadian Society for Civil Engineering's National History Committee, and I'm pleased to host today's tripartite webinar for the new Transatlantic Cable series on the achievements of civil engineers and civil engineering in the UK and North America. So, welcome, and indeed we're going to run the Transatlantic Cable today. We have a busy hour planned. I will explain the tripartite webinar program. Then I'll introduce today's speaker, Tonja Koob Marking. Once she has given her presentation, we will have time for discussion, questions, and answers before wrapping up. The American Society of Civil Engineers, the Canadian Society for Civil Engineering, and the Institution of Civil Engineers are the learned societies for civil engineering in their respective countries. They were formed to establish, develop, and maintain high levels of practice in civil engineering, and that involves communication of best practice and learning from the past. The tripartite webinars have been created to enhance interaction between the societies and to learn from the past. Civil engineering history does not recognize international borders, so the history committees of the three societies present topics that involve at least two of the participating societies. Now it's my great pleasure to introduce Dr. Tonja Koob Marking to give today's talk. She is the past chairwoman of the ASCE History and Heritage Committee and owner of GA Consultants based in New Orleans. The firm specializes in coastal and civil engineering as well as hydrology and hydraulics. So it's very appropriate that Tonja talks about George Vancouver's mapping of the northwest coast of North America. Tonja, the floor is yours.
Thank you, Nigel. So again, thank you, Nigel, for that lovely introduction. It is my honor to present this webinar today, and I truly appreciate the invitation to do so. So my talk today will be our voyage of discovery of George Vancouver's surveying and mapping of the northwest coast of North America. And in the spirit of this tripartite webinar series, Canada, the United States, and Britain are all major players in this topic. So we have George Vancouver, and we've got his birth and death dates here, 1757 to 1798, with a portrait that is attributed to him. There are no known definitive portraits of George Vancouver. However, the consensus has been that this portrait, which is in the British National Portrait Gallery, is indeed George Vancouver, and it was painted shortly after his return from this voyage and prior to his death, obviously, which happened just a few short years after his return. In looking at this portrait and the globe behind him, I found it rather interesting and perhaps a bit ironic that the map for North America, for America and Canada, in fact, does not reflect his maps. Now, his maps were not produced until after his death, and so that is to be expected. But for what he is known with his incredible mapping, the map appears to me to be the coast of North America more from Cook's surveys and do not incorporate the improvements of those surveys that Vancouver did as part of his 5-year journey. So why was Vancouver going to survey the northern coast of North America? He had 2 directives. One of them was political, which I will not discuss in this webinar, and that was to attend the treaty and convention with Spain after there were issues with Spain capturing and confiscating some British territory and fur trader vessels. So he needed to go and represent the British government to sign the convention and move forward with that political situation. For our interest today, we will be looking at his 2 directives on determining whether a route for a Northwest Passage existed through North America. And then secondly, to survey and map the western coast of North America between the latitudes of 30 and 60 degrees north. And so specifically, his scope of charge was, quote, acquire accurate information with respect to the nature and extent of any water communication, which may tend in any considerable degree to facilitate an intercourse for the purpose of commerce between the Northwest coast and the country of the opposite side of that continent, unquote. So he was to survey inlets or large rivers, to note the direction and the extent of those inlets or large rivers, but to not survey any further any navigable water body if it could not be traversed by an ocean-going vessel. So afterwards, specifically, we can talk about the Columbia River and his survey. He was criticized for not fully surveying that river, and in his defense, doing so was not part of his scope of charge, specifically because of the shoaling problem that was at the mouth of the Columbia River. So Vancouver, if nothing else, was very strict to his scope of charge, to following his mission, and did not stray from that mission for a couple of reasons. One, he wasn't paid to do any of that extra work, even though he did end up doing extra work and had to fight for additional compensation. And secondly, because the British government gave him only 3 years to accomplish surveying from 30 degrees to 60 degrees latitude north. And so putting that in geographical terms, that would be essentially from Baja California in northern Mexico up to Cook's Inlet. So surveying that in the late 1700s in 3 years was quite a task. While he was at sea, he was expected to make daily observations and to obtain latitude and longitude of islands, of harbors, and to keep a daily journal of all of his observations. And then when he was on shore, he was also expected to obtain latitude and longitude with similar observations, and to observe the tidal ranges and times of high and low water. So let's examine a little bit these aspects of his mission. What was the interest for the Northwest Passage? Specifically, Europeans were interested in a shorter route to what they termed at that time the Orient. So they wanted a shorter route for trade between Europe and India, China, that area. There was a lack of scientific knowledge about the conditions in North America. For instance, some people believed that seawater was incapable of freezing. And so even to the mid-17th century, Captain Cook was reporting that Antarctic icebergs had yielded fresh water. So this is confirming this hypothesis that seawater was incapable of freezing, which led theoretical geographers and explorers to surmise that an open water route close to the North Pole certainly must exist. On top of that, there were early explorers in the 1500s, one of them being the Greek explorer Juan de Fuca, who was exploring on behalf of Spain, was surveying this area and supposedly discovered a strait. And I say supposedly because both Cook and Vancouver didn't believe that this strait existed. They thought it was a myth. And Juan de Fuca was certain that this existed and it would be the entrance to a Northwest Passage connecting through, as you see on this map, rivers, major lakes, through to Hudson Bay. So just to orient you on this image, this is from circa 1790. And here on the west, this is the coast of North America. So down here at the south, we have Catalina. And as we go north, this is Nootka, which is on present day Vancouver Island. And then if we continue to go north, we end up at Cook's Inlet, which at that time was known as Cook's River. Then if we look from the east side, we have Hudson Bay, and we can see these rivers, these extended streams that are connecting to large lakes. And so the theory was, if significantly detailed survey from the west side could identify this inlet that Juan de Fuca claimed to exist, they would be able to connect the western side of the continent to the eastern side of the continent, thereby shortening the distance and travel time to go from Europe to East Asia. Again, just for scale, this also includes southern part of North America, and where my cursor is, this is the Mississippi River. And again, following my cursor, this is the Missouri River. So if we look at the Mississippi River, we can see from this manuscript map that through a series of islands or lakes, there could be a connection all the way into Canada and then east to Hudson Bay, which we know at this time does not exist. So moving forward, we have this map from also 1790. And John Meares was a fur trader. So one thing to keep in mind about fur traders is that they were more familiar with land routes than sea routes and other water routes. And also, their job was not to take detailed measurements. It was not to record observations in journals and log books. And so there was interpretation and knowledge of these topographic features, but not necessarily the ability to locate them in space and to fully understand how these water features were connecting across the continent. So what we see here in 1790 with John Meares's map is this is more closely reflects the Western survey of the continent that includes the data from Cook. And so we can see down here, ultimately, we have the Strait of Juan de Fuca, which is where my cursor is right here. And then this would be Vancouver Island. Here we have Queen Charlotte Islands. And then upward to, again, Cook's Inlet, which at that time was known as Cook's River. which we can see in the upper right-hand corner. And they were projecting that a river, Cook's River, would go from that inlet all the way to Slave Lake and then exit Slave Lake through Slave River and could connect eastward. So it wasn't a foolhardy notion that a Northwest Passage could exist. But again, it was theoretical at that time because it had not been determined specifically through navigation, the likes of which Vancouver was directed to perform. So that was his first mission. The second part of his mission was to conduct these surveys. So if we think about surveying at the time of the late 1700s, we need to put it in context of what capabilities those surveyors had. So first, if we look at surveying old school, so I'm calling it older school, navigators and surveyors were using dead reckoning at that time. And so dead reckoning is a process of calculating that the current position of your vessel based on a previously known position of your vessel. And then you advance forward to identify what your current position is based on your estimated speeds, your elapsed time to get from point A to point B. So while dead reckoning can give the best available information on a present position with little math or analyses, it's subject to significant errors of approximation. And so for precise positional information, both the speed and the direction must be accurately known at all times during travel. And in this era, that could be challenging. So dead reckoning does not account for directional drift as it's traveling through the water. And these errors tend to compound themselves over greater distances. And so that makes dead reckoning a difficult method of navigation and surveying for longer journeys. That said, with this image, we can see that even as late as the 1920s to 1930s, the US Coast and Geodetic Survey was still publishing their dead reckoning lines as they went back into this area and were updating surveys. So how would the explorers and the surveyors at that time get these measurements, and what was their frequency to get dead reckoning with the least amount of errors possible? So first, they would take one reading every hour on the hour and record that. And then they would take two readings after every speed change. And then third, they would take three readings after every course change. So again, dead reckoning is all relative positioning based on a known location. Then, as the survey technology advanced, I'm now calling this old school. So it's not as old as dead reckoning. It is a technological advancement. This was the use of lunar observations aided by calculations in the nautical manual. So here we have an image of the Nautical Almanac from the year 1775, and chose to share December since we are in December of 1775. So to find this positioning using lunar observations and the Nautical Almanac was helping to zero in on a longitudinal reading. And longitude was much more difficult to determine than latitude because the Earth's rotation continually changes the longitudinal position of a point on the Earth's surface with respect to all the celestial objects. To calculate your longitude at sea, you need to be able to compare the time on the ship to a time at a port where the longitude is known. And so this meant keeping an accurate time for days, which frankly was impossible with the 18th century clock technology. Nonetheless, this is an advancement to dead reckoning. So what information was in the nautical almanacs? So we can see here that for December, we have all the days of the months. They're reading the sun's longitude. They are looking at declination. They are looking at the satellites of Jupiter. And where were those satellites positioned on what days? These tables were created for every year, and the navigators and the surveyors would bring them these books with them to help better define the latitude and longitude of the areas that they're surveying. So these almanacs were no joke, right? We've got a lot of information here. Again, they are trying to read these celestial bodies to help them figure out where they are in space on the Earth's surface, even as the Earth keeps rotating. This is just for the month of December. We can see that we are looking at all these distances and where they are with respect to the phase of the moon, the satellites in Jupiter. And if anyone is interested, you can read the explanations and use of this from 1775. And one key thing, as we were looking at all those dates and times, the time always went from noon. So the day started at noon. The day did not start at midnight. And at noon was always when the navigators and surveyors were taking their readings to determine longitude. So the day started at noon. Finally, we make it to new school. We are no longer at old school surveying. We are at new school surveying. And this is the use of the chronometer. During Cook's journeys or his surveys around the world, Vancouver was on his second and third journey. And Vancouver joined as a midshipman on Cook's second voyage at the age of 14. So he was an officer in training at the age of 14, and part of his training was to learn to navigate and to survey. So at Cook's time, they had dead reckoning, they had the lunar observations with the nautical almanac, and then they also had chronometers. So this is the K3 chronometer. This image and the chronometer is at the British Maritime Museum in Greenwich. This was commissioned by the Board of Longitude. It was completed in 1775. So Cook took this with him on his third voyage, which Vancouver was a part of. And Vancouver was able to take that same chronometer with him on his voyage to explore the northwest coast of America. Here is a further image of the inside of the chronometer. And so how this worked and how it improved surveying was if you measured the position of a celestial body with a sextant, and then you know the exact time of the measurement, then you can determine the ship's longitude from these published tables. So time was important. You needed to know the exact time. And so a typical marine chronometer, it was mounted on suspension devices called gimbals. And that was so that they would stay in horizontal positions while they were on the ship so that they could move in all of the dimensions as the ship rose and fell and rocked, all of that. So it could stay level to maintain the precision and the accuracy of time necessary so that exact longitudes could be determined. And here we can see inscribed on this is London. It is a Kendall chronometer, that's the K, from 1774. So if we look at the sextant, this is our navigation instrument used to measure the angles, and particularly it was to measure the altitude of the sun and stars above the horizon. And so the sextant was used to find the position on Earth, to find the latitude and the longitude. This particular image is George Vancouver's sextant that he used when he was on Cook's third voyage. So typically, these marine sextants, they have this triangular frame. They've got the curved scale. We've got the degrees that are marked in the arc at the bottom. And then they're mounted on a frame. So it has an eyepiece and a piece of glass, and that's called the horizon mirror. And then half of that glass is silvered and the other half is clear. So the sextant is held so that the horizon can be seen through the clear part of the glass when you're looking through the eyepiece. And then attached to that frame is a movable arm that crosses the scale. And on the arm is a second mirror. So the arm is positioned so that the image of the reference body, say, for example, the sun, appears in the horizon mirror to be just touching the horizon. And then the position of the arm along the scale gives the altitude of that body in degrees. So with the exact time noted on an extremely accurate clock, which was the chronometer, the altitude of the body and the correct time and the nautical almanac, the observer can determine where the ship is in a line on a position. And so then if you take a second sextant reading an hour or two later, and then you have that second line of position established, the intersection of these two lines together with the ship's course and speed will give you the latitude and longitude. So with this, we can understand more fully the advances in survey technology in the late 1700s by the time Vancouver was surveying the northwest coast of North America, which is why, in addition to his attention to detail and expecting that same level of performance from all of his crew, Vancouver was able to so accurately create these maps that some of them were still in use more than 100 years later. And just for a little history fun fact, you can see how Vancouver had his name engraved in his sextant. And I will say that I got this image from an auction house, which you can see in the watermark on here. It's previously sold, but that is to say, engineering history is still available for purchase, even if it is more than 200 years later, for engineering history enthusiasts who like having artifacts. These artifacts still exist, and some of them are even outside of museums. Now we know what Vancouver was charged to do. That was to determine whether a Northwest Passage existed through the northern part of North America and to survey the northwest coast of North America. So how did he get there? If we look at this map, he left Falmouth, UK on April 1st, 1791. Now this red line I drew. So this is my interpretation. This is not his exact line of sailing. There are maps that are available. Those lines were a little hard to read, so I just generally traced his path. So please do not interpret this as this was his exact sailing line. He and the crew had a little running joke leaving England on April 1st, April Fool's Day. I think probably at some points during the voyage, they wonder if they were truly on a fool's errand. But ultimately, they were not, and we have them to be thankful for. So we can see that they left England in April. They came around Africa, and traveled to the south of Australia. And then if we look over on the left side, they continued past southern New Zealand, made their way into Tahiti and French Polynesia, came north to the Sandwich Islands, which is Hawaii, and made it to Cape Mendocino mid-April 1792, where they could start their surveying. So it took this crew a full year to get from their starting point of their voyage to where they needed to begin their survey. 1 year. So let's talk about this survey with a little more modern map so that we can understand truly what an accomplishment this was over a 3-year period. So this is a more modern map. I got this from Fisher, and taking the extents that the survey achieved over each of the 3 years while it was out there surveying, we can see the progress that Vancouver made with his surveying crew. So first they started further south, still in the United States. They came up from Cape Mendocino, they went through Monterey and started coming up north. In April to August of 1792, they surveyed from Cape Mendocino all the way up to Burke Channel. And then that would be until August, and the weather starts turning, and they were not going to continue surveying through the bad northern weather. So then from October to December, they moved south and they surveyed the Columbia River, came down as far as Monterey, and went over to Hawaii. And they stayed in Hawaii from January to March of 1793 and started surveying the Hawaiian Islands, the Sandwich Islands. And then as the weather improved, they came back north and they picked up where they left off from Burke Channel, and they made it up to about Clarence Strait. So that's what they did the next survey year, from April to September of 1793. And then again, they went back south and surveyed all the way down to Baja, California in Mexico, because again, his scope of charge was from 30 degrees to 60 degrees north. And then they went back to Hawaii. So from January to March of 1794, they were in Hawaii. So they would survey in the summer up north, make their way south, and winter in Hawaii, which I interpret that as Vancouver and his crew were the first snowbirds. For the third year of the survey effort, Vancouver decided to go from north to south. So he left Hawaii in March, made his way up north, up to Cook Inlet, and then started coming back south. And you can see the area where I circled. The last area that they surveyed, they named that Port Conclusion, which I thought was rather appropriate. So with the scope of charge complete, they started making their way back to England. And from August 1794 to September 1795, again, almost a 1-year journey to get back to England, they came the other direction. They went past the Galapagos Islands, they went past Cape Horn, and then made it to England. So part of this survey effort included a circumnavigation of the globe. How did they survey? Because ultimately these maps were the final product, but how did they survey on land and on sea to create these maps and to determine that there was not a Northwest Passage? What they would do if they were on open stretches of coastline. So they had a long, fairly straight coastline. they did a running survey. The way they performed the running survey was they had their vessel moving offshore far enough to observe multiple prominent features on the shore. And then they would establish a ship station to determine the compass bearing of these prominent features. So in establishing the ship bearing, they had to go through, they had done dead reckoning, they used lunar observations, and they were using the sextant and the chronometer. So they established ship stations. And then they could determine the compass bearings of those prominent features. And they took soundings, and then they would move to the next ship station, making sure they could still see some of those earlier prominent features so that they could keep tying in the new part of the coast that they were surveying with the part of the coast that they had previously surveyed. So they would establish a new ship station. They determined the distance that they had traveled with a log line. And then they made a rough sketch of the coastline that the ship had just sailed. So they got their markers by the prominent points, whether those were promontories or maybe they were recessions, or was it in an island? Was it some kind of significant feature? And then, weather permitting, every day at noon, they would determine the latitude and longitude of where they were. So that was the running survey. And that was possible when there were long stretches of coastline. For all of us familiar with the Pacific Northwest, we know that that is not what the coastline looks like as you get further north. As they got further north, they had to establish onshore observatories. And here's a watercolor of the boat encampment from Puget Sound in the Strait of Juan de Fuca. So, one, they have now conclusively determined that the Strait of Juan de Fuca did in fact exist. It wasn't the supposed strait as Cook believed, it was the actual strait. It did exist. So they would set up these onshore observatories. They established fixed positions so that all the other measurements could be reconciled to that point. They would establish a baseline. If there was enough flat territory, it might be 1 mile with a chain. They would identify the major points, the landmarks, the shoals. They would identify those by fixing these intersecting angles with the sextant, and they would protract them right there on the spot. And then they use the compass to determine the meridian and observe its variation. And so this, in essence, was a rudimentary triangulation scheme. And then you would plot it on your chart. And then you would move your base camp and you would do it again. And you would move your base camp and you would do it again. And then each time after collecting this data, whether it took a couple weeks, the data would come back to the ship. And again, they were establishing these base camps in smaller boats because the larger ship could not make its way. It didn't have sufficient draft to get into the Strait of Juan de Fuca. So they had to use the smaller boats, rowing, oaring. 1 year, 10,000 miles by oaring with boats because they could not use those ocean-going vessels. So this was a major, major effort. But you did a little piece, shared that information back on the master chart that Vancouver had on the Discovery, his flagship Discovery, and then you would move your base camp and you would do it again and move your base camp and do it again. And through that process, Vancouver created these incredible maps of the northwest coast of North America that we have come to know. And so here is an example of one of his maps. And this is the map of Vancouver Island. And so we can see, first off, we look at this incredible level of detail. Here's Vancouver Island. Here is the Strait of Juan de Fuca. With this survey, it was conclusively determined that Vancouver Island was actually an island. Prior to that, navigators and surveyors thought that the island was actually part of the mainland. So conclusively determined that Vancouver Island was indeed an island. So here we have a section that also has some insets. We've got the entrance of the Columbia River, we have Grace Harbor, and we have Port Discovery. It's interesting that if you read the note that is on this map, and actually all the other maps, it says the parts that are not shaded are taken from Spanish authorities. So yes, Spain was in this area also doing surveying. The Spanish surveyors and the British surveyors did encounter each other. They had a cordial relationship. They had settled the treaty at Nootka. They shared information with each other. But Vancouver was still particular to designate which parts he surveyed per his scope of charge and which parts he got survey information from the Spanish surveyors. Also included on these maps, which you can't see in great detail, are dashed lines and dotted lines. And so if you look at the route with the unbroken line, and then we have the route with the dotted line. So the northern route is with the solid line, and then the southern route that the survey crews took are the dotted lines. So you can see what their route was when they were going north, when they were going south. You can see some of those soundings. And then you also see this amazing topography that's drawn in with the mountains, with the islands, with the hills. The detail of these water bodies is just incredible. Again, thinking back to those 1790 maps, this is just so far beyond even what Cook had done and Meares had done. So if we move a little further north, we can see the next map in his series. And so here we've got the map is going from Kings Island, British Columbia, up to Admiralty Island. So now we have Queen Charlotte's Island right here. And we can see really this, they're calling it an archipelago of all of these islands. We've got Prince Frederick Sound up here. And this is how Vancouver was able to conclusively determine that there was not a Northwest Passage despite all these openings and inlets along this coast. Because again, part of their scope of charge, they would sail up these inlets as far as they could, and they either had to turn around when they got to the end of it, or if they could no longer navigate, sometimes the ground crews would go a little bit further, but also would be talking to some of the local communities, the indigenous people. They knew very well what their land was. They'd been living there for 10,000 years. The European surveyors did not always take for truth what the local people were telling them, but it did provide some insight, and they would go in and survey to conclusively determine with their methods the extent, length, and navigability of these inlets. This is further north. We are looking all the way up around Kodiak Island, Alaska. And here we can see now called Cook's Inlet. So this was a situation where Cook, the mentor, and Vancouver, the protege had to correct the mentor because Cook had not gone far enough into this opening to determine that it was just an inlet and it was not a river. It was late during his voyage, the weather was getting bad, and Cook was like, you know what, I'm done, and just did not explore as far as he could have. And thus he named that Cook's River, which contributed to the idea that a Northwest Passage did exist connecting to Slave Lake, Slave River, ultimately over to Port Hudson. So with this, the protege was able to conclusively determine this was not a river, it was an inlet, and he renamed it. Again, it's showing the routes. Any areas that are not shaded was information that came from the Spanish. So I would just like to share one of the Hawaiian, this was the Sandwich Islands, the Hawaiian map that Vancouver's crew created. And it was Cook who named what we now call Hawaii, the Sandwich Islands. And he named that in honor of the 4th Earl of Sandwich, who was then the First Lord of the Admiralty. So that's where the name, the Sandwich Islands, came from. So Cook found these on his 3rd voyage, and he died there on a subsequent visit during his 3rd voyage. And Vancouver was on that voyage. So Vancouver definitely had some complicated feelings about going to Hawaii because that was where his mentor was killed. A connection with the British government and Hawaii was that within 5 years of Cook's arrival, European military technology had helped the ruler of the king of the island of Hawaii, that was Kamehameha, to conquer the entire island and unify this and establish the Kingdom of Hawaii in 1795. And so if you look at the Hawaiian flag, the Union Jack is part of the Hawaiian flag. And it goes back to this connection between the British Admiralty, the surveyors, the explorers, and that military technology that they brought with them that helped the island king consolidate the islands under one rule. This was a prosperous island. It was important for agriculture and strategic location in the Pacific Ocean. And so the British government had a keen interest in this. So I'd like to wrap this up with looking at Vancouver's historic significance. And we've mentioned a lot of these during this talk. First, he confirmed that the Northwest Passage did not exist through the North American continent. Later, a passage was discovered that went through the islands closer to the North Pole, but one did not exist through the North American continent. Also, he replaced Cook's simple map with his very detailed maps, which were still in use in the late 1800s, particularly around Alaska. So on those maps, they were of such significance that they were utilized in the settlement of the Oregon boundary dispute between the United States and England in 1846. Lewis and Clark used Vancouver's maps for their exploration of the newly purchased Louisiana Territory. And it influenced the current boundaries of British Columbia and Alaska and Washington State. He named nearly 400 places. A lot of those are still in use today, not all of them, but he was naming them after crew members. So if we think of Whidbey Island or Puget Sound, Whidbey and Puget were part of his crew. He named them after politicians like Port Townsend, or places in England like Wimbledon Point, or even events that happened along the voyage like Cape Caution, or Safety Cove, or Escape Point, and Foulweather Bluff. Lastly, a historic significance is the opening of the coast to commerce and exploitation. And this was by Europeans, it was by Russians, it also had Asian influence. So yes, there was commerce and there was exploitation of natural resources, of human resources, and that is of historic significance. I think that it is important to highlight accomplishments as well as we have positive impacts and we have negative impacts. And to have a full understanding of the role, not only in civil engineering history, but also in economic and social history, we need to recognize and acknowledge both the positive and the negative. So, in wrapping up my talk, here are some suggestions for some further exploration and discovery on your own. The Voyage of Discovery, which is the 3-volume report of Vancouver's journey, was issued in 1798. Vancouver scholars now are definitely leaning on the Lamb edition from 1984, where it is fully annotated. But as I mentioned, history is still for sale. And here is a full copy. You can see all of these. I'm not paid in any way by the seller. $45,000, you can have an original copy of the 1798 edition of A Voyage of Discovery. A book that I highly recommend is From Maps to Metaphors, The Pacific World of George Vancouver. It has great chapters on chronometers, on surveying methods, on the Northwest Passage, on interaction with local communities. Also, Vancouver's Voyage, Charting the Northwest Coast, the book Longitude. And so that's the story about the chronometer. And here with YouTube, we also have a BBC production that's not working right now, so I'm just going to close it. There's a 30-minute BBC production that talks about the chronometers and how the chronometers change the world. There is a movie that was released in 2000, which is very good, and I highly recommend it. That's based on the discovery of the development of the chronometer. And then lastly, where I was getting so many of these fabulous Vancouver map images, is the David Rumsey map collection. Again, this link will be available in the chat section. High resolution scanned images, and you are free to download those. So with that, I am concluding my talk, and I am available for questions if there are any. Thank you very much.
Thank you, Tonja, for that really excellent and informative talk. Really appreciate that. There were a couple of questions to be asked, but I really honestly don't think we have time for question and answer. We're almost up to time. I'd just like to let everybody know that the next of the Tripartite seminars will be on February 1st, all things being well. Nicholas Bill is the speaker, and he's a senior lecturer in the School of Engineering at Cardiff University in the UK. And he's going to present, as you can see the title there. So we would really appreciate you putting that day and time, it'll be the same time as these, in your calendar. And we would very much like to see you then. In the meantime, we'll wish you very happy holidays and a wonderful new year. And we'll see you in February. Thank you for attending.
Thank you.
The new transatlantic cable webinars are coordinated by a tripartite ad hoc committee that includes the individuals listed here.